Hey, this is Mr. Weisbrod. We're talking about physics questions today. Today's question from the Regents exam in physics for the state of New York, Tuesday, June 17, 1977. These are exams given to all high school students that were hoping to go to college. And so let's see here. What do we got? All right. Displacement time graph below represents the motion of a cart along a straight line. During which interval was the cart accelerating? So we look at the graph. This is constant displacement right here versus time. This is not moving. Okay, if it's not moving, it's not accelerating, so it's not C and D. This right here, D to E, this is displacement is getting less, so this is negative velocity. How do I know it's negative velocity? Well, on a displacement versus time curve, I'm going to take x2 minus x1 all over t2 minus t1. Or more specifically, let's do x at E minus x at D all over t at E minus t at D. Since x at E is less than x at D, this is going to be a negative number. So this is negative. Time is always positive, especially increasing on the graph. And so this is going to be overall a negative velocity. But why is it velocity? It's velocity because it's displacement divided by time. So remember that velocity equals distance divided by time. And you could also say displacement. There's no problem with that. Displacement divided by time. So those things are all velocity. So similarly, I think you could see that this part of the graph right here, from B to C, so it's not D to E. From B to C, similar, you could see that's positive velocity for the same reasoning. Since x at C is greater than x at B, so the displacement at C is greater than the displacement at B, it's at positive velocity. Time is positive. So the only interval at which the cart is accelerating must be AB. And that's because the slope of the curve is the velocity. So we haven't said that yet, but we've seen that here. Slope is velocity. And when we have these regions of constant slope here, B and C, and then DE, we've got no acceleration. But in this case, if the slope is a velocity and my slope is increasing from A to B, then it must be that the interval where the car is accelerating is A to B, because the velocity is changing from A to B. A to B, and in particular, it's increasing. There we go.